In this video of electrostatics, we are going to derive an expression for finding electric field at a point R away from a rod of length L having charge Q. So, for a rod of length L having charge Q uniformly distributed over it for any point situated at a distance R, we will calculate the electric field. Now, as we have seen previously, to find electric field for continuous charge distribution, we follow three simple steps. First, we select a tiny element, then we find its electric field, and final step is to integrate for the whole body. The limits for integration will vary from case to case. Now, for this one, the first step, we select the tiny element over here having charge dq, having length dx, situated at the distance x from the perpendicular distance r. Therefore, the distance between dq and the point of interest will be square root of x square plus r square. Here we will have the angle of inclination, let us denote it by theta. Therefore, at this point, the electric field due to dq will be pointing in this direction. Let us call it as dE. Now, dE will have components along x-axis and y-axis. Let us label it as dEx and dEy. Now, if this is theta, this angle will also be theta. From this arrangement, it is clear that all the components of dEx will cancel out each other, because for every component along the positive x-axis, there will be an equal and opposite component along the negative x-axis. Therefore, the resultant charge due to the entire rod will be only due to the y component. Therefore, dEy equals to dE cos theta. So that will be equals to k dq upon square root of x square plus r square the whole square, that will remove the square root, into cos theta. Now, to simplify the expression, we usually get the integration part for one variable. Therefore, here we shall substitute for cos theta as r upon square root of x square plus r square, and since we have uniform charge distribution, q by L will be equals to dq by dx, and therefore dq will be q by L into dx. Substituting these two values in the expression for dEy, we get dEy will be equals to kq dx upon L into x square plus r square into r upon square root of x square plus r square. Now, for our final step, we integrate. Total electric field will be equals to integration of dEy, that will be integration of the entire term. Here k, q, r and l are constants, so they are removed from the integration sign. We will be integrating from minus L by 2 to plus L by 2, assuming that the origin is situated at the center of the rod. So here we will be integrating for dx the whole upon, here x square plus r square into square root of x square plus r square becomes x square plus r square the whole raised to 3 by 2. Now, this mathematical part of integration, I am leaving it up to you, your mathematics teacher. You can go ask them for the steps of this simplification. Here we will substitute its value directly. So, k, q, r by L as it is, integration of this entire term is x upon r square into bracket x square plus r square raised to 1 by 2, having limits minus L by 2 to plus L by 2. Now, for the case of simplicity, instead of applying limits minus L by 2 to plus L by 2, we can simply apply twice from 0 to L by 2. So, applying the limits, we get 2kqr the whole upon L into r square. Here instead of x, we substitute L by 2 the whole upon square root of, again instead of x, L by 2. So, L by 2 square plus r square minus 0, you don't need to write. Now, cancelling out the common terms. So we are left with kq by r into 1 upon square root of L square by 4 plus r square. Simplifying it further, we get 2kq by r into bracket 1 upon square root of L square plus 4r square. So your final expression for electric field at a point r from a rod is given by E equals to 2kq upon r into square root of L square plus 4r square. Now after every derivation we have to cross verify whether the final expression is correct or not. So we assume that instead of a rod of length L, we have a point charge where L can be negligible. If you substitute L equals to 0 in this expression, it has to simplify to kq by r square. And since it does, that means this expression is correct. Now for the special case of this one, you have to find electric field due to a rod of infinite length. We have the expression for electric field due to the rod of length L. Now if you imagine a rod of infinite length, then the distance r is negligible in comparison to L. Therefore in this expression we can neglect the r square term when added to L square. Therefore we have 2k cube by r into L. Now if lambda is the linear charge density, then lambda will be equals to q by L. So here instead of q by L we can write lambda. So the expression for electric field due to a rod of infinite length will be E equals to 2k lambda by r, where lambda is linear charge density. These types of special cases are very common in entrance exam questions. So you can try to build an understanding about what variations can be asked regarding the object whose equation or whose electric field you already know. Now, how will you simplify if the point was at infinite distance from the rod? Leave your answers in the comments.